All right, number 11. He gives us a function and wants us to algebraically find the x-intercept and the y-intercept. In other words, by hand. Okay, I could graph it and see where they cross the x-axis, y-axis, but let me use my brain here. X-intercept, that's the x-axis. Where is it crossing this guy? Well, if I think of this point right here, I've moved over some amount. I don't know how far, but I know I've moved up how much? None. You actually know that the y value has to be 0 if you're crossing that y-axis. So we're going to set the y value equal to 0 when we're finding the x-intercept. For the y-intercept, well, maybe you're up here on the y-axis. You've moved over none and up some amount. Here we know the x value has to be 0, so we'll set the x to 0. So let's start with the harder one, which is always the x-intercept. Now, it says f of x, function notation. That's the same as y. So this equation is the same as y is equal to x minus 2. Find us the x-intercept and the y-intercept. Okay, so we have this equation. You already know y's value has to be what? 0. So I'm going to replace that y with a 0, and then I can solve for x. Add 2, x is equal to 2. So I know it crosses at x being 2, and the y, as always, will be, in this case, 0. Let's find the y-intercept. Again, the equation is f of x, or y equals x minus 2. I'm simply going to replace that x. I know it's 0 in the problem when I'm crossing the y-intercept. So y is equal to 0 minus 2, so y is negative 2. I have x's value. I now have y's value. So it's crossing at 0, negative 2. So that's simple. All right, so here we are with this guy. Now, it's a little bit more of a challenge, but again, x-intercept, we know we'll set the y value to 0. For y-intercept, we set the x value equal to 0 because that's always going to be true. So this is y equals. So I'm going to set the y to 0. Right here, I'm setting this piece, this y equals the equation, to 0. So I need to find the x. Wow! What number squared plus 3 times the number minus 10 equals 0? That's a parabola. If it's an x squared, it's a parabola. That tells me it's probably going to cross in 2 spots. Let's find the 2. Also, dead ringer. As soon as I see it's a trinomial, I'm like, hey, that bad boy's going to have to factor. So I got to break 10 down. 10 is a 1 and a 10, 2 and a 5. It is negative 10. Wow, they're making this difficult. It's a negative 10. So one of the pieces is negative, one is positive. So we're looking for the difference. These have a difference of 9. These have a difference of 3. That's who we're looking for. So I know it's the 2 and the 5. Now, again, difference of 3, but you need it to be a plus 3. So the plus is going to go on the 5, the negative on the 2. That way you end up with a plus 3. So this is x minus 2 times an x plus 5. And all that equals a 0. So we're not even done yet. Oh my goodness. So what do? Well, if two things multiplied together give you 0, one of the two pieces has to be 0. So I know this x minus 2 has to come out to be 0, or maybe the x plus 5 has to come out to be 0. Well, I add 2 to both sides, I get 2. Subtract 5 from both sides, negative 5. There are my two x's. So x being 2, the y being 0, the other spot it's crossing when x is negative 5 and y is 0. Again, the x-intercept takes a little bit of time. Watch how quickly the y-intercept goes. I simply take the equation y equals x squared, which we know the x is what? 0. So 0 squared plus 3 times 0 minus 10. Boom, 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 negative 10. So it crosses at x being 0, y being negative 10.